This episode of the 2019 Integrated Data Viewer Intermediate Topics series will cover three-dimensional trajectory plotting. If you plan to plot trajectories over a large domain, check out Episode 7, Two-Dimensional Trajectories. We'll start by opening the Hurricane Michael bundle. The lines that you see here are called 3D flow vectors. In IDV speak, 3D flow vectors are like trajectories except that their starting point sample a volume instead of a plane. 3D flow vectors are great for seeing the big picture dynamics of a system, while trajectories highlight the details of the flow. To show you the trajectories, I'll have to hide the 3D flow vectors. We'll use the same dataset so that you don't have to compare apples and oranges. Grid 3D trajectory is another three-dimensional momentum-derived parameter. There are a few things to watch out for with your data when you're making this type of plot. All three components of velocity have to be included in every time step you select. This means that you should always skip the first time step when using GFS output, which doesn't have vertical velocity. Calculating trajectories is also computationally expensive, so it's best to limit your time steps and display region. Unlike every other time I've hit Create Display in this video series, this time the display isn't actually created. Instead, we get a drawing control interface disguised as the display. The drawing control isn't usually exposed to the user. Most of the time, you access it through another type of display without even realizing it. The IDV is open source, so if you're brave enough to dive into the code, you can see for yourself how essential the drawing control is. There are a few ways to choose the starting points for your trajectory. I'll start by showing you a horizontal starting area. Since there's a hurricane in the domain, we should probably pick a pressure level lower than 1000 HPA. I'll do 750 and start with a rectangle. After hitting the radio button, you need to click and drag on the map view to tell the IDV which rectangle you want. It's a simple click and drag, you don't need to hold the shift key or anything. It might take a few minutes for your rectangle to appear and to grow to the size that you chose, so be patient with this. Finally, we can create the trajectory. This is what actually creates the display. The first time step isn't much to look at, but it develops as you advance the animation. If you look from the side, you'll see that all of the points are in the same plane. Even though we'd expect the height of the pressure level to vary, we're using pressure coordinates. Plots like this are good if you want to see how a particular layer advects. Now I'll switch displays so that you can compare this to the 3D flow vectors. They're fairly similar, even though the different displays are useful in different situations. You can also see the advection of a latitudinal or longitudinal cross-section with trajectories. These are chosen by index, where 0 is the left or bottom of your wireframe box. We'll do a longitudinal sheet first. There's also a button that you may have noticed to plot a backwards trajectory. A backwards trajectory shows the path of the parcels to, rather than from, the plane of origin. It's not the best for visualizing dynamics, but it is great if you want to know where the air in a certain area came from for moisture, aerosol, or pollution analysis. Just so that you can see a non-backwards vertical plane of origin, I'll make a latitudinal sheet as well. This, like the horizontal plane, makes a plot that's great for seeing the details of dynamical systems. However, the vertical plane makes it easier to see vertical motions, while the horizontal plane highlights horizontal motions. If you have any questions, please visit our website at unidata.ucar.edu or email us at support-idv@unidata.ucar.edu.